Okay, so how do we turn this number into scientific notation? The first thing I do is reduce this number, right, to a number that's between 1 and 10, not including 10. So the only way to do that is to put a decimal between the 1 and the 8. That gives me 1.8, which is between 1 and 10. And if I put it anywhere else, for example, if I made it 0.18, that's below 1, that's too small. 1.8 fits, right, but for example, 18 does not, that's above 10. 180 doesn't fit as well, and so forth, right? The only place that I can put a decimal to create a number that's between 1 and 10 is between the 1 and the 8. So with that said, we're writing this in scientific notation, and that's the first step for me, right? This first number, the coefficient, has to be larger than or equal to 1, but less than 10. Now, we can't change the number. This should still be 1 billion, right? This is 1 billion, 800 million, right? We don't want to change the number. We're just changing the way we're writing it. So we have to multiply 1.8 by what? Well, we have to multiply it by 10 enough times to equal 1.8 billion. So essentially what we did was we took the decimal, which was here, and we moved it all the way to here, between the 1 and the 8. So we took the number and made it 3, 6, 9 powers of 10 smaller. So to balance this number out, to return this number back to 1.8 billion, we have to multiply it by 10 3, 6, 9 times. So this would in fact be 10 to the 9th power. And if you think about why that makes sense, right? Every time you multiply by a number of 10, you move your decimal to the right. For example, if you have 5 and you multiply it by 10, that becomes 50. Notice the decimal moved from after the 5 to after the 0. It moved to the right. So if you multiply 1.8 by 10 9 times, you'll move the decimal back 9 times. So it'll go 1 and then 8 more times, which will produce, of course, 8 zeros, right? 3, 4, 5, 6, 7, 8. And that is the original number we started with, 1.8 billion. All right, thanks.